today I'm going to. I think that day, the previous session, actually, I taught you how to establish BGP neighbor relationships. But here, actually, I'm planning to, uh, explain um, how to, how to change the selected path, or how to change the routing path using something called BGP attributes. Because when it comes to Azure deployments, this is pretty much mandatory, because let me draw a diagram and tell you the importance of this understanding of this BGP path selection. Okay, let me get my whiteboard. Whiteboard is here, and one moment. Uh, I don't know how to draw on this. I have no idea. One moment. Let me change. Using this, can I change it? Yes, I can change it. Okay. 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 Let me. Okay. Let me draw it here. What happens is, let's say. Let me draw this. Let's say you have. Let's say you have this Azure. Let's say this is your Azure firewall, right? Sorry, I'm really sorry. One moment. Okay. So here you have this. Let's say you have two Azure firewalls. Firewall cluster. Actually, you have a cluster, right? So then, actually, behind your firewalls, you have these networks. You have behind these, you have your networks. These are two Azure firewalls. And let's say you have on-premise network. I think you asked that question that day. You actually, this is important. You have on-premise network, and here let's say you have some this on-premise firewall here. Let's say that firewall also a parallel firewall. This is your on-premise firewall, and since you have two separate firewalls, these two firewalls are not actual HA, right? Because when it comes to actual HA, what we have to do is we can have just one single IPsec tunnel here. But the problem is, since these two firewalls are two separate firewalls, actually we have to have two what you call two IPsec tunnels to this on-prem firewall. This is one firewall, one IPsec tunnel, and this is your second IPsec tunnel. Okay, so then so the traffic, let's say if this, because behind your firewalls, actually you have a load balancer here. Here you have a load balancer. Actually, next session, the 10th session, I'm doing this. Here you have a load balancer, and load balancer is putting traffic between these two firewalls, right? So let's say if load balancer is going to send traffic to this firewall, so then let's say that the traffic is destined to this network, on-prem network. So then the traffic can traverse through this tunnel, and let's say some traffic is sent to this firewall. So then the traffic can traverse through this tunnel. So in that case, actually we need to have some kind of uh, routing protocol in order to manage this, because the problem is, let's say if this traffic is coming through this tunnel and reach this network, and but let's say if that traffic is going to send, the return traffic is going to send through this return traffic is going to send this tunnel, that would be a problem, because this firewall doesn't have any idea about this traffic, right? So then this firewall is going to drop that traffic. So actually that is the main thing. So here I'm going to explain you how to how to manipulate the active path in BGP. So that is the thing. So let me clear this. Okay, so let me do this. Okay, let me move to my second screen. Here, sorry. Okay. One moment. What happened? Okay, so you can see my screen, right? Okay. 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 So let me show you my the diagram here. Actually, I'm doing this using the EVNG, but the scenario is the same. But here for this understanding, actually, I have one firewall. Using this firewall, actually, I can show you the actual path selection using BGP. So actually, when it comes to Shabas in BGP, what we need is we have something called attributes, BGP attributes. Using BGP, I'm sorry, using BGP attributes, actually we can manipulate the path. So here we have two paths. You can see we have two paths, right? So here we have two paths, and we can manipulate the path using BGP attributes. So that's what I'm going to showcase here. Let me try to draw here, but I don't know why I can't draw in the second screen. Can I get it here? No, I can't. One moment. Capture the screen. What is this? Just stop 1 second. Then let us know. Okay, let me try this. Uh, okay, I think you can see my screen, right? Yes, you can see my screen. Okay, here I have this network because I cannot draw by keeping it in the second screen, so that's why move to this screen. Okay, let's say what happens is here, Shabas, actually this is my let's say head office, and here I have a web server. uh, so I need to advertise that I have to advertise that network into this. Let's say we have a branch with let's say in Australia, in Australian branch office, so that's what we need to do. uh, so here initially let me configure this route firewall. Here actually my AS number is 64,512, and I think you are familiar with this because we did it already. And let me go here and let me configure, because at this moment let me show you I do not have any let me go to BGP and BGP peers. I do not have here. This is uh, one moment. What is this? This is status is active, right? Because this is from previous one. This is I don't have any connected BGP peer. Let me see whether I have any configuration here. BGP and I do have here or export import. No, I don't have anything. But here it's enable. It's okay. It's enable. It's okay, no problem. Okay, let me do this. Let me put the route ID here. Let me get the network. Let me get the network here. Let's say I'm just putting, let's say this IP 10021. So there is a upper path. I'm just I have planned to name these two paths. Let's say the upper path. The first path is, let's say, upper path. Let me put that name. I think it's easy. Let's say this path as upper path. Okay, this one is called, let's say, upper path. Upper, let's say, upper path, and let's say this path is called let's say lower path. This is lower path. Okay, So then what I'm going to do is I'm going to enable BGP here. Okay. Okay. So here enable, and the router ID is, let's say, 10021, and is number 64,512, because actually I use the previous why it says invalid IP address. Sorry, 10021. This number is 64,512. Actually, I had to put the number, but it was already filled because of previous demo. But it's okay. And here, let me go to peer group. Now I had to create two peer groups here. So because actually using two peer groups, actually I can manipulate this what you call BGP attributes, Shabazz. Actually, I had to manipulate in this scenario. I'm planning to manipulate two BGP attributes. I'll tell you those two before the configuration. But initially, let's establish the BGP relationship. Okay, let me go here and peer group, and let me put the first peer group. Let's say name upper group, because actually upper group means here I'm using the above the first link. Because I can establish two BGP relationships, right? So let me show you. I can establish one BGP relationship using this link, this way, and another BGP relationship using this link. Both the links. I can have these two BGP relationships. So here upper one is I'm going to treat as upper path, and the below one is the lower path. Okay, so let's remove this. Okay, so then I go here and let me put upper group, and the relay. This should be IBGP, because this is a internal port gateway protocol, right? Okay, and then the peer, and here the peer name is, let's say, lower peer. Sorry, upper peer. Actually, I'm coming upper one, upper peer. And here the interface should be, let me check, the interface is Ethernet 1/2, Ethernet 1/2, and the IP address is this one, 10021, and the remote IP or the peer IP should be 10022. This is my sorry, 10022. That is my upper peer. Okay, upper peer means this firewall is going to establish a neighbor relationship using above link. So this is a single router, I know, but this firewall see this router from two links, because let's say these two paths are using two different redundant paths. So that means if this path is going to be down, but the lower path is not going to be down, because those are not using the same ISPs and all. So that's my plan. Okay, so then okay, now let me go back to the firewall, and now our upper one is configured. Let me click OK, and before the lower one, I think I can just show you. Let me click OK, and let me commit. Or otherwise, let's configure both. I think we don't have to worry that much, because since we have already done this upper group, and let me configure the lower group. This is the lower group, and here this should be IBGP and the peer. Then this is a lower peer, and here interface should be Ethernet 1/1, and the IP address should be this, and the remote type is 10012. Okay, now we have configured both the peers. Let me click OK. And before checking this peer status, I had to configure this within the router as well. Okay, let me go to this router, Open. Let me change the font size, appearance, change. Okay. Let me configure the router. Okay, configuration terminal, and let's say router BGP 64512, and neighbor, let's say 10011, and remote AS is 64512. This is the first name command. Okay, first name is done. The second neighbor, then see, first name is up. Neighbor 10021, remote AS 64512. Sorry. Now I configure the second neighbor as well. See, the second neighbor is also up. So let me save this configuration and let me go to the firewall, and let me go to more runtime stats. Now I should be able to see both the firewalls, both the neighbors. Actually, same neighbor via two links in the established state. Let me go up here. See, it's established. So that means this is fine. Okay, now we have to advertise networks. First, we'll advertise both the networks. Okay, so here my first network is this. My actual network is this network 192.168.200.0. Let me do that using the firewall. Let me go to default virtual router, and let me go to redistribution profiles, and let me add this redistribution profile. Okay, here let me put, let's say, this webnet, and let me put the priority 1, and let me enable redistribution, and this is a connected network, and interface is, this interface is 1/3, interface Ethernet 1/3, and that is fine. This is enough. Okay, and let me go to BGP and redistribute, and let me add this network here. Okay, I selected it. Let me click OK, and let me click OK, and before committing, let me go to the firewall and show you. I think this is a file, right? BGP table, show IP BGP. See, I do not have anything here. Show IP BGP. I do not have any BGP. But if I'm going to show IP BGP summary, I will be able to see the neighbors. See, I have two neighbors, 1 and 2 1. So that's fine. Okay, so then let me go and commit. Because actually in this scenario, I'm totally focusing on the Palo side, how to manipulate BGP attributes using the Palo firewall. Because since you are focusing on Palo Alto, so using that knowledge, actually you can do these things when it comes to Azure, because same configuration. So let's wait for the commit. Okay, now we have advertised our network using the Palo Alto firewall BGP configuration. So let's go to router and see whether we can see those networks. Okay, let me go here, and previously we used show IPBGP, it was empty. Now see, now we have when I use the same command, I show IPBGP, I have 192.168.200 network received through BGP, and it says this caret, I think this is called caret sign, right? Caret, yeah, I think caret sign, I guess. So using using this sign, it says the preferred path. So it says 10.0.1.1. Actually, that is the lower path. I think lower path, right? Because its range is 10.0.1. So this router, yes, this router. Okay, this router preferred accessing 192.168.200 range, this range, using this path. It is by default it is selected. Okay, so for the moment I'm going to keep it as it is. I'm not going to change it. So then let me go to my this what you call route and advertise this network, because actually we have two way, right? Because this web, if I want to access this web server, this way actually if I want to access this web server here using this network also going to be advertised to this firewall, because otherwise the response traffic cannot the response traffic won't get received by this network when we access the web server. Okay, so then let me advertise using the router, its network. Okay, let me go to configuration mode and router BGP 64,112, and this is the command network. This is not that much important for you. 172, because before that let me go and showcase that I don't have such a router within my BGP in Palo Alto. Let me go to more runtime stat. Let me go to BGP and local brief. See, I don't have 172 network here. Now I'm going to advertise it. 172.16.1.0. Here it says mask 255. I think you can remember in OSPF actually we had to put this wildcard mask, right? But here the subnet mask. Let me enter. Now it's fine. I have advertised it. So let me go back to the Palo Alto firewall and let me see I can see that in the BGP table. See, now I have that. I have learned via two paths, and here also it I think it prefers the lower path. See this asterisk mark in the 10.0.1.2, that is this path. 10.0.1.2 engine is the lower path, right? So the 10.0.1.2 is this this point. This point. Let me show you that this point. So it preferred this path. So traffic is planning to traverse this path. So let's check whether we can access it now. Let me go to, actually previously I didn't show you because I think you know when there's no routing we cannot actually access. Now let me try to access, since we have this routing advertised. Yeah, okay. But see, I cannot access still. I think I know the reason. Let me go to the firewall and let me open the virtual router and let me go to BGP section and one moment. Okay, we use webnet, that is fine. Okay, here let me go to BGP. Here I didn't put the install route because it is not in the routing table. Let me click OK. And before committing, let me show you that 172 range is not within the routing table. See, we don't have any 172 range here. Let me commit. Once commit is done, we should be able to ping the web server using the Australian network. Okay, so then Shabazz, our plan is to move this the lower, actually the active path is lower path, right? 1.0.1.0/30 network is used for this traffic now, but I want to move it to the upper path. We can do that using something called BGP attributes. So that is a path selection mechanism in BGP, because I think you can remember in OSPF actually it's a cost when we have a number of routers and there's another thing that is a the speed of the path, and those things are main reason for the path selection. But here actually it's a totally manual process. We can do it. Okay, let me go here. Now let me go here and show you that now it should be visible here. 172 range. See, now it's visible. Now I should be able to see successful ping. See, it is getting we are getting the successful ping. Okay, now what I'm just keep that ping running, and what I'm going to do is I need to swap this path into the upper path now, because now it's using the below path. Now currently it's using this path. I want to use this one instead of the below path or the lower path. I want to use the upper path. So if I want to use the upper path, the first thing is from the here this parallel to firewall in the BGP table, I should be able to see. I think you can remember that 17 to 16 range. When it comes to 17 to 16 range entry, the asterisk or the star mark with the with this part. Star mark with this part. So let me show you that. Let me go to runtime stats and let me go to BGP and peer, not peer, local read. See here, this is the star mark, right? Star mark is 10012. Next stop is 10012. I want the star mark to be put into this entry. I want 10022 should be the next stop for this 17 to 16. That is the first requirement. And the second requirement is, let me go to router. Let me go to router. Sorry, show IP BGP. Here also you can see this sign. I think here that sign name is Carrot. Sorry, the sign here is belong with the lower path 10011 range, but I need that sign to be moved to this one 10021. So those are the two requirements, because then what happens is when let me go to diagram. What happens is when we move those things, traffic from this router, when I initiate a ping or try to access the web server, the traffic is going to follow this path, because if I'm going to move the caret mark into the above path, so the next stop of 10022, the traffic is going to use this path. And within the parallel to firewall also, if you're going to move that asterisk mark into the upper path, so the return traffic also coming through this path. So that is the thing. So that's what I need. So let's do that using BGP attributes. Let me remove this and this. It's easy, not that much complex. So let me go to firewall, and now you see this is in the second line, right? The asterisk is in the second line. Here what we are going to do is, when I think I need to draw this. Let me get my pen. There's something called BGP wait attribute called wait. So what happens is, when we have this parallel to firewall, and when we have this router here, and there's a network, and this network is learned via the BGP, right? You learn via this path and also this path, since we have upper path and lower path. Okay. So when the parallel to firewall learn this path, learn this network, we can change the weight of this route. Weight of this route. So what we have to do is, we have to put a weighting, some higher weight when it is learning through this higher path. If this route is learning through this or the upper path, we are going to increase the weight using something called here import rule. Using import rule, we are going to put higher weight for the route advertisement learn via the higher path, but we are not going to change anything in the lower path. So then, since it has a higher weight, the parallel to firewall is going to prefer this upper path. This attribute is called weight. Okay, so let's do that. After doing this, I'll explain it again. So I'm going to increase the weight of the route that is learned via the upper path. So how can I do it? Okay, let me go to virtual router, and here let me go to BGP, and let me go to import rule, because actually route is I'm receiving the route because I'm receiving that route from the other router. Import and here let's say wait, you can put whatever the name. Let's wait and or something, And here I'm not going to use match, because actually I'm going to increase the weight for all the routes received by the upper path, because actually I'm receiving only the one destination, one network, right, using the upper path. That is the Australian network. In the action section, I can put weight. Let me set weight. Let's say I'm putting the weight 100, because before that I had to check the weight of the car. Let me go back. Let me check the weight. I had to check the current weight here. Let me go to BGP and let me go to local trip. Let me see whether we have any weight here. See, weight is 0. So if I'm going to put 10 here, the parallel file is going to prefer this path. If when the parallel file wants to access 172.168.1 dot network, it's going to use the next stop of 10.0.22. That means the upper path. But currently asterisk mark is with this entry. So that means currently this, when the parallel to firewall wants to contact 172.168.1 dot network, parallel to firewall is going to send the traffic to 10.0.12. That is the lower path. Let me show you. Currently firewall is going to use this path. When it wants to access 172 network, it's sending the traffic through this path. But what I'm going to do is I'm going to changing the weight attribute. I'm going to force parallel to firewall to use this path. Okay, that's what I'm going to do. Okay, let me go here and now see the asterisk mark is here, but I'm going to change it to this place by increasing this weight. Okay, let me do that. Okay, let me go to BGP and let me go to import, because actually I'm learning this route. I'm importing this route, right? So because of that, I have to use the import rule. Okay, rule name. Let's say this is weight and action, and I'm putting just 10 because the default is 0, right? I'm just putting 10. Okay, so then here in general section, I'm asking firewall, please use this role for this upper group, because I want to increase the weight of the upper link, right? When receiving the route, I want to increase the weight when it is received through the upper link, because currently it uses the lower path. I want the upper path to be the active. Okay, now let me click OK and click OK. And before committing, let me show that again. Let me go to BGP and local brief. See, it's here now. It's going to be changed to this place. Let's see whether it's going to be happen, because this weight is going to be 10. Let me commit. And also I have to show you one thing that is important. Let me show you. The ping is now currently working, but once we change this, this ping is going to stop. I tell you the reason for that as well. See, currently ping is working, right? Okay, let me commit. We'll wait for the commit, because when it comes to parallel to firewall, all the, not parallel to, but when it comes to all the routing devices we have, or the networking, we have something called asymmetric routing. So here when we change that preferred path from the or the preferred next stop or the path from the parallel to firewall in, actually there's a asymmetric routing environment will be created. So I tell you and I'll explain it to you. Okay, now it's almost committed. Okay, before that, let me go here and show you that change here. BGP local rip. See, the asterisk mark is with this first entry now. Previously it was here. Now the weight is 10. Previously it was 0. Now what happens is parallel to firewall prefer this path when it's sending the return traffic back to this Australian network. This path, not this path. Now our ping should stop. See, ping is not working. Ping is not working. The reason is, Shabas, this is important. So reason is, what happens is, actually this router is using this path, because this router prefer this path, and traffic is going to this firewall, and firewall is going to accept it and send this traffic to this backend network. And when the backend network respond, the return traffic is going to be sent via this path. This is asymmetric routing. The problem is this coming into the firewall using this interface and going out using this interface. So that is a problem. The problem is actually Palo Alto firewall checks the zone, the incoming zone and outgoing zone. If those are two different, Palo Alto firewall is going to drop the traffic. So that's it. So actually, that's a problem. So what we have to do is, because actually let me go to firewall and show you. We have two different zones for those two interfaces. But if we have same zone, this traffic would work, because Palo Alto firewall doesn't care about the interface but the zone. Okay, see here. Let me first Ethernet 1/1 is it's OSPF. Sorry, the firewall is from the previous session. The zone is OSPF, no problem. They're just a zone, right? And the 1/2 is in OSPF 2. See, that's a problem. So because of that, this firewall doesn't, is actually drop the traffic. So that's the thing. So actually, that is asymmetric routing. Traffic is actually coming into this firewall using this lower path, and when this web server responds, the return traffic is going back to the router using upper path. So that's the thing. So now what we have to do is, as a first thing, I can show you that if the zone is same, so this traffic would work. So if you want to understand that, let me show that. Here, see, this is not working, right? Uh, but okay, I'll show that and I'll revert it and do this routing manipulation, because I need to manipulate this one as well, because I want this router to force to use the upper path as the Palo Alto firewall, because currently it is using the lower path. The lower path is 10.0.1, right? Okay, let me go to router and let me show you that. And show IP BGP. See, the router is using the lower path. The sign is with the lower path 10.0.1.1, but this should be changed to this way, this position. So I can do it using the Palo Alto firewall itself. I don't want to change anything within the router. From the router end also can be done, but since we are focusing on Palo Alto, we'll try to do it on the Palo Alto firewall. Okay, so but I want to show you this as well. If traffic is even though traffic is coming in from one interface and going out through another interface, if the zone is same, Palo Alto firewall is allow that traffic. But here, since the two zones, it is not doing. So but I'll show that and revert it, and they'll show that second configuration of BGP attribute manipulation. Okay, here let me change the second interface or zone to the same OSPF zone, because this is important. Let me click OK and come in. So once I do that, okay, let's wait for the commit, because okay, now it's almost done. Let me okay, it's done, showers. Let me go here and see, the ping is working now, because actually let me go to the diagram. The thing is actually actually traffic is traffic is coming through this path, because actually the router preferred this path. Traffic is coming to the Palo Alto firewall, and firewall is going to send the traffic back to the whatever the VM. Yes, we have a VM. This VM, and then this VM, and then when the VM responds, the firewall is going to send the return traffic through this upper path, because since we have changed the weight in the Palo Alto firewall learned this this Australian network using the upper path, since we have increased the weight of that path for that network. So this is asymmetric routing, because this is coming this way and going this way. So but this is working since we are having the same zone. Because see, now ping is working, and also we have a web server that is also accessible. See, it's a web server. See, it is accessible. And let me change that back to the previous state, uh, because it makes more clear that when you change the router configuration, I mean using the Palo Alto firewall, this ping is going to be start again. Let me change this to OSPF2 again. Okay. Don't worry about this name OSPF, because actually I used the previous firewall. I did not change any interface configurations. I use the same. Okay, now it is completed. Okay, let me go to the VM and see whether I have ping. No, ping has stopped. Ping has stopped, right? Okay, now what we are going to do is we are going to manipulate the router, the preferred path. The router is using the lower path, still using the slower path. I'm going to change that preference. So what I'm going to do is, let me explain it first. Here we have this. Here we have the Palo Alto firewall, and here we have the router, and we have two paths, and both are in the same AS number, because this is important. When these two devices are in the same AS number, when this router is actually Palo Alto firewall is advertising this network, right, 192.168.200, this network, it advertises using both the links. So when it advertises, what we can do is we can increase the local preference, something called local preference of this route through this path, the first path or the upper path. So then this router is going to use that higher local preference advertisement, and it's refer it, and it's going to put it in the routing table since its local preference is high. Local preference. Local preference. Local preference. But since this is local, means local to is autonomous system, because these devices have same autonomous system. But if you have some other autonomous system, this local preference is not going to be propagated to that autonomous system. Oh, what is this? Sorry. How to close this? Okay. See, here I have the same autonomous system here. The same autonomous system. Okay, that's it. And I'm going to use the local preference. I'm going to change the local preference of that route advertised from the Palo Alto firewall. So then that is going to be received by the router, and router is going to prefer that path, the upper path. That's what I'm going to do. Okay. Okay, let me remove this and let me configure that. Before that, let me confirm that router is using the lower path. Let me go to the router and try BGP. Here you can see right here 10.0.1.1 is the preferred path. That's why this sign, this greater than or lesser than, no, greater than, right? This sign is here. This sign should be shifted to this section, this entry. So that's what I'm going to do using the Palo Alto firewall local preference. Let me go to Palo Alto firewall and let me go to virtual routers. And before that, let me clear this stuff and okay, let me open the default virtual router, and here let me go to BGP, and this is export, actually exporter, right, because I'm exporting an route advertisement, exporting, not importing. I'm sending it to the below router or the Australian router through two paths. Okay, I'm adding export rule. Okay, here I'm going to not match, because actually I'm just exporting a one. Otherwise, you can tell only this rule is going to be applied to this network, only that network or something like that. But since I'm exporting only one, I'm not going to tell anything about here match. I'm going to action section, and here I have local preference. But before that, we have to identify the default local preference, because this local preference should be higher than the default local preference. Let me go to router and let me see the local preference. See, local preference is 100. So then I had put some higher value to this mark. So this local preference should be higher than this. So then this mark is going to be put it to this, and the router is going to use this path to reach the Palo Alto firewall network. Okay, now what I'm going to do is let's say 200. I'm putting 200. Okay, and this is going to be used by the upper group, because I want to change the advertisement are going through the upper group, right? Okay, let me put a name. Let's say local pref. Okay, so let me click OK. Now let me commit. So once I commit this, the two things happen. This value should be changed to 200, and this mark should be shifted to this place. So let's see. Let's wait for the commit first. I think Shabazz, you can just practice these things, so then you know these things. You can apply these things to anywhere, even show or whatever the place, because this is pretty much important. Okay, so then it's 99 completed, and okay, let me go here now. Check this new state of this entry. So let me remove these things first. Okay, let me enter. See, now it's 200, and this mark has been shifted to this place. And also you should be able to see successful thing now. Let me log in here. See, now ping is working, because actually the thing is Shabazz. So let me go back to this network, and what happens is when this router, when it comes to router is sending traffic using the upper path, and when it reaches to Palo Alto firewall, it is going to send it to the backend web server, and the return traffic also going to be sent through this upper path. So then there is no asymmetric routing. So firewall is accepting it. But previously the problem was actually the router is sending traffic through this path, and the Palo Alto is sending the return traffic through this path. So that is called asymmetric routing. So that means it's like this traffic is coming this way and going out this way. So that is called asymmetric routing. Actually, we use two things within BGP. We use BGP attributes. Actually, BGP attributes are the things that or the attributes are the things that we are using to manipulate the path selection. So actually, we initially use something called weight, right? We use weight, and then we use local preference. What we did was initially, when this this Australian network is learned by the Palo Alto firewall, so we increase the weight. We increase the weight of that route learned. So then Palo Alto firewall is going to prefer this path, and then we advertise. When we advertise this, this backend, the Palo Alto firewall backend network into the router, so we increase the local preference for this upper path. So then the router started to prefer this path. That's what we did. Actually, we use weight and the local preference in order to manipulate the path. So that is totally important. So I think Shabazz, you understood how we can use these BGP attributes. Actually, there are so many attributes, and we have something called mate, and we have ace path, and we have route ID. We have so many BGP attributes, but here actually I use these two BGP attributes in order to give you the basic idea how we can manipulate the path selection using BGP attributes. But I think with this understanding, you can dig deep and you can do whatever the configuration using BGP.